Out in an interactive session, and the first exercise is basically to rank the most important topics to discuss during the session. This is what is happening now. This is a complex exercise. Two things are very one, you need to find someone else in the room in random, and you need to exchange the post-it, and at the same time introduce yourself. Yeah? So just name, alright. And this is the second step. Third step. Once you receive it, put a score between 1 to 5 on the paper. How interesting you think that topic is. All right? 1 to 5. 1 being less interesting, 5 really hot. We need to cover that. All right? 1 to 5. 5 being hottest, 1 being very superficial. We don't need to cover. All right? So after you're going to take already the first two, kind of mindset, and I'm going to put also the one on developers and testers as a first step. Alright. Let's start first getting some terminology in place, introduction to some of the core concepts. Now, what you see here is a famous painting, actually. Anyone knows what this painting is? Sorry? This is actually called the Potato Eaters. It says has been done by a famous artist whose name is Van Gogh. You heard about Van Gogh? Now, Van Gogh had a very interesting style of working when he was developing his art and his paintings. He was a very experimenting kind of an artist. He would typically start by some sketches like this, just using a piece of paper and some pen or coal, and just start scribbling and drawing, just to examine the composition of different objects on the painting. So, for example, as you see here, he was experimenting with having people sitting around the table, and he was thinking, I might have some door coming in somewhere where the light would be coming in. Now, he would do that and spend a lot of time in experimenting, prototyping, creating a lot of so-called studies. Afterwards, he put a bit more detail, as you can see here. Looking, for example, at more of the kind of typical construct of where people should be positioned and where should light be coming from. Once he has finished a couple of those, he might even do 4 or 5 of those. He will go to the next stage, which is starting putting some color. Now, by the way, there's a couple of paintings here in the bottom here. Which one do you think is the last masterpiece? Right or left? Actually, this is the one that is now in the museum. If you go to Holland, you see this on the museum actually. Even though it's quite dark and gloomy, but that is what we wanted to do. Now, if you also look at it, there was this lady here. She was standing up, and he decided later on to put her on the left side. Then he decided to make her sit down, and at the end, she was still sitting but leaning forward a bit. Now, he had this concept he was using this concept of working in more of an iterative, agile manner. In a sense, he doesn't know exactly, he has an idea about what he wants to accomplish, but he wants to find his way through by creating a lot of prototypes, examining, experimenting until he reaches the end result. Now, this means that sometimes you create 2, 3 studies before getting to the final work. Sometimes you will have like 20 different experiments, prototypes, of which he will be gaining more knowledge about what he wants, and then he can, of course, agree with himself about what is the approach I want to take and what is the right thing for me. Now, in software development, there are different approaches of how to develop software, how to develop systems. Most software development processes follow a model. And the idea is, the model will describe all the phases from conception through implementation to delivery use in some kind of a structured approach. Now, irrespective of what kind of development methodology you're using, it typically has these phases. Specification, which is about initiating the project, determining what requirements we should have. Design, sometimes you can have high-level design and then low-level design. It can be both from a user requirement point of view, it can also be from a technical point of view, like technical design specification and user requirement specification. Then you have implementation, which is typically the construction and coding, or putting the pieces of code together. Testing, surprise. Sometimes, point in time, we need to verify that we're meeting the requirements, both the implicit and explicit requirements. And this can be done through what is called verification, validation, QA activities. QA activities is also to support the entire life cycle, making sure that you've also applied the needed levels of testing before getting into the actual testing phase. And then you have maintenance after going live. Someone needs to take care of it once it's there, it's been in operation, so to speak. There'll be, of course, some, after going live, there might be some change requests coming in, there might be some users asking for more features, or there might be some bugs to have split. So it's slipped into production, that needs to be fixed and corrected. So you might go through that process multiple times. All right. So if we take a step back, before going into the industry of developing software and systems, people were doing a lot of manufacturing. The industrial era started, of course, where people were doing mass production of different things. And the first idea was, once people started doing system and software development, is to replicate the same model that we use in manufacturing. Meaning that, by constructing a house or building, or having a mass production of, for example, a certain item, let's say, for example, producing this glass, then you have certain activities you need to go through. And the idea was behind it that you proceed to a subsequent phase once you have completed the former stage. So, for example, after meeting the exit criteria of specify, you're then allowed to move into the next phase, which is design. You work in design, and you keep working in that until you have fulfilled the exit criteria of that particular stage. Once you've done that, you go into construction, and so integration, testing, training, deployment, maintenance. All right? Now, the idea behind that, of course, the emphasis is on planning. So you need upfront, you need to agree on what requirements you should have, freeze those, and the idea is, once you have frozen those, you then take that as a basis for the design phase. Now, the phases, the entry and exit criteria I mentioned before, these are typically known as quality gates. Before going from start to integrate, you typically have a quality gate, making sure that you have met the exit criteria from the former stage, and you're also meeting the entry criteria of the next stage. Now, very important thing is, once finalized, requirement are frozen, like carved in stone. Yeah, you've created, got the whole thing. Now these are the basis for all next activities. All right. Now, throughout, the evolution in software development, there have been different models that have been used for that. Now, one of the first nice evolutions coming from the sequential model was so-called V model. And I think most of you have come across this model, yeah? I think so. Now, why is it called a V model? Anyone? Shape is I still want to see if you're still awake. Yeah. So this is basically the V model. The idea is, and it's a nice model. Why? Because first of all, it shows chronologically exactly how the different activities are split. So you're starting with the requirement specification, then you have system specification, high-level design, low design coding, unit testing, integration testing, system testing, user testing. Now there might be some fine tuning of that. So you might, in certain areas, you might in the organization be called something differently, or you might actually be splitting some activities into sub-activities. So for example, you might also have, after system testing, you might have system integration testing. You might, within user acceptance testing, you might also split that up into multiple sub-activities. I'll get back to that later. And the good thing also about the demo is that it also shows that for each phase or for each activity on the left-hand side, you also have a corresponding testing activity on the right side of the demo. So for example, for low-level design, the activities that go hand in hand with that is unit testing. So it means that here, developers are doing the design of the actual components, and the phase that goes into that is actually verifying these components. This is unit testing. Same here, low-level, high-level design is about verifying the interfaces work. So the focus on the right side will be making sure that the interfaces will work across the components, not the components themselves, but the interface between the components and the passing of the data from one component to another. System requirement specification, you have system testing that goes hand in hand with that. And the idea is to make sure that from a system point of view, you're meeting the requirements that you have in the system requirement specification. At the end, of course, user acceptance testing that you are meeting the requirements of the user. Now, when you hear the concept of what we call shift left, you've heard that throughout the conference, the idea is to try to start with these activities here as early as possible on the left side. And we'll be discussing this throughout this afternoon, discuss what ideas can we implement here. Now, some organizations, they have refined this and have created a W model, like putting two V models on top of each other. And the idea is, for each level here, you have the planning of the testing going hand in hand with that. And the validation of the individual activities on the right side. I'll get back to this also. All right. So, let me just pause for a second. What are the main advantages of using the V model? Anyone?
Less defect because we have more testing.
Less defects, we have more testing. And how come you have more testing? Because you have multiple phases?
We started from the unit testing. Sometimes we have two testing and the system testing and integration.
All right, so what you're saying is that you have more testing in a V model. I'll park that for a while. I will not agree or disagree at the moment. We'll get back to this and discuss it when we discuss Agile as well. Other points, other advantages?
So that you can cover both static and dynamic testing. Static and dynamic.
You have both static and dynamic.
Validation and verification.
All right, you have a clear segregation of this. Excellent. Other views? What are the main advantages?
Starting testing earlier.
You can start testing earlier? How come? I mean, he obviously you won't be able to start anything before we have coding, yeah? So he can only start after having at least some coding has been developed, yeah? So you mean you can start planning early? You can start planning. That's
So
great.
in sequential, you only start it after you finish all the earlier phases.
Yes. I was asking for about the advantage of the sequential model, or waterfall model. Other points? I'll park that for a while. Other points?
More easier for planning, I mean for the project to plan.
Excellent point. Obviously, since requirements are frozen, it's very easy to do the planning because you already know we have the foundation is not being changed. Now, we'll discuss a bit more about advantages. What are the main disadvantages using this model? Anyone?
Static. It's too rigid.
Too rigid?
Yeah.
How do you mean what rigid in what form?
Because you need to finish every single process before you can move to another. So when let's say there's a change in later part, you have to go back and change everything or not. That's okay.
Very good point. Basically, since everything is frozen, if you want to make any change, how do you implement a change? A change can be quite expensive because it means that you need to reopen the requirements, add additional requirements, and go through the same process once again. So changes can be difficult in that sense. Other disadvantages? Time consuming? Well, nothing stops you from doing short demos, but to a certain extent, yes, because basically, for example, the requirement specification itself can be, since you're specifying an entire system, it can take a lot of significant time to develop all the requirement specification, all the requirements for the system. It can be time consuming, that's correct. All right. So, we'll get back to it in a while. I'm just, I'll keep leaving those open for us for a while. A study that was done by Berding back in 2001, they're trying to quantify, the whole conference is about ROI, yeah? So they're trying to put a dollar value on the cost of correcting defects across the different life cycles, yeah? So they came to the number $139 if you find a defect in the requirement. Then it will only cost you $139 to fix. In a sense, this is the effort required. Basically, this is the cost of the effort required to fix the requirement stage. Yeah? Once it goes into design, the price goes up. Coding goes up to $1,000. Then it can get up to $7,000 and $14,000 if it goes, into maintenance, meaning after going live. Now, imagine that you see the door over there. I want to move the door just half a meter to the right, yes? Now, if I do that while I still have the blueprint, it's quite easy, isn't it? You go in there, delete it, just move it half a meter to the right. Very cheap, yeah? Of course, I still need to make sure that the construction still can hold and everything, that's a different story. But at least moving half a meter to the right is not a big issue. Imagine that we have, now I want to do it now, after it's gone live, I want to move it to the right. You think it's expensive? Quite expensive. Just half a meter can be extremely expensive. Now, this is the kind of thought process that goes into your point also, that if you want to make changes at the later stages, it can be very expensive. Because the effort associated with that will be very high. Now, interestingly, let me ask you actually, where do you think most defects are being introduced? If you look at the entire life cycle, you have requirement specification, you have design, detailed design, where are we introducing most of the defects? Any idea? UAT, introducing. No, not finding. Where are you introducing those defects? Requirements. Actually, some studies have been made to look at where are we putting all the defects in. And the studies, there's not only one study, there are multiple studies, show that most defects can go back to the requirement phase. Either wrong requirements, missing requirement, wrongly interpreted requirement, and so forth. Sometimes, we were discussing in the other